Good morning, everyone. Today, I'd like to talk about one of the most important system contract called ContractDeployer, which I put in the middle because it's very important. This is the system contract that is responsible for deploying smart contract on the blockchain. I think if you look at a blockchain, two aspects are important. One is the deployment of contracts. The other is, of course, the execution of transactions. So almost like the two pillars of blockchain applications. So let's look at ContractDeployer. And along with the ContractDeployer, we are going to talk about two other system contractor. One is called AcountCodeStorage. Let me make all these three red to emphasize the importance. Okay. So let's shape a field red, shape a field red, shape a field red, just to emphasize importance. Maybe change this to a white. Okay, just bear with me the time. I hope it's going to pay off by emphasizing a little bit about these three contracts. We can pay a little bit more attention to its functionalities. Okay, so let's get into we will probably touch other, like a nonce holder and MSG value simulator, L2-based token, or even immutable simulator. I think all of the other contracts were touched by today's discussion, but we will focus on these three, okay? Interestingly, we can talk about the three because that means it's not that complicated. Otherwise, we have to have several videos. So one video is sufficient, amazingly. So let's look at the ContractDeployer. First of all, the ContractDeployer manages the so-called account information because one of the things that Zksync has featured, I don't think they promote this concept too much, is they have this notion called account, which is unifying more between wallet address UA and the smart contract, in my understanding, okay? In addition, you can support more information about either smart contract or UA as account information. So just consider account is a unified concept between wallet address and smart contract, all right? So you can get account information. Let's look at when we talk about account information, let's look at what it's all about. So account information basically have two components. One is how you use the nonce. We previously in the nonce holder talk about you can either use it sequentially or you can use it kind of randomly. So this is an additional feature of using nonce. In addition, you can save a value for the nonce. That's the advanced feature for account. And the other one is simply right now is supported AA version, advanced account version. So that means in the future, they might, redefine the account information so that you can use this supported AA version to differentiate what version are using. Right now, it's just version 1, okay? So that means account information very much right now is just managing the nonce ordering, but it could be more in the future. So you get account information, retrieve the account information. Basically, as we said, it's just the non-ordering, the ordering or the nonce ordering information. And then we can get the extended account version, which is basically just get the first field of the account information. And if it's not equal to 0, that means you already have the information encoded. So all you need to do is just return it. Otherwise, if it's equal to 0, That means it's not supported yet. Then we have to check if it's UI. If it's UI, then we are going to return version 1. So, which is what, so it's checking if it's greater than system contract account, it's a regular user, and then the local hash in the account storage system contract is 0. So in other words, there's no code deployed here yet. Okay. Maybe another way is you can also check the code size, but code size is a little bit dangerous because if you check code size, maybe during deployment, its code size is 0. So, so this is a way to get the raw code hash, and then you return it, otherwise it's 0. This allows you to set a new account information. We can also change the version. This is both of them is like this is only system call, and then this is just change the nonce ordering over here. One restriction is require the nonce ordering input argument. So this is a validation of the input argument. Either have to be sequential or arbitrary. Only 2 values are supported. And then it's going to be, let me see. Oh, okay. So the nonce ordering, if you want to change it, the current one has to be sequential. You cannot change it from arbitrary to sequential. You can only change from sequential to arbitrary. So this condition 1, the condition 1 is to ensure that the new ordering is not arbitrary, and then also to ensure the old ordering is not not sequential. Okay, the old ordering is not sequential because you don't want to change from sequential to. Let me see. I'm a little bit confused. Okay, so the first condition say the new ordering cannot be arbitrary because you cannot change from sequential to arbitrary. Only allow sequential to arbitrary, yes. So only allow sequential to arbitrary. So this one say if it's not equal to arbitrary, the new one is not equal to arbitrary, then we are in trouble. If this one is not equal to if the new one, if the old one is not equal to sequential, we are also in trouble. So the old one has to be sequential. I'm not used to read the if statement. Maybe the require statement may be better. So the require statement, we have to change the negation. So basically, it's going to be this has to be equal. So the new one has to be equal to arbitrary. And then the old one, so this debug column one is the end. And the old one has to be equal to the existing one has to be equal to sequential. Okay. Yeah, I think change this to require will be much easier to understand. So then change it, and then you store account information in the mapping. I think this is a mapping we put over here. This is a mapping. Okay. And then in addition, we are going to, and then the next one is we can get the predict the address using creator2. So one of the things that ContractDeployer support is create or creator2. Creator2, the address is predicted, it's known. So so the way you get it is you construct the put hash. Construct this is this input is for the constructor arguments. So we calculate the input hash, constructor input hash, and then we are going to concatenate with the prefix like usual. And then I think this prefix is also different from Ethereum prefix, so that they avoid address collision. And then this is a sender, which is the deployer or the factory, the sort. And then the bytecode hash is the most important topic, which is I believe it's a creation code. Oh, I'm sorry, it's the bytecode hash over here. And then we have the constructor input hash, which is calculated right here. And then we calculate the hash eventually and return that is a hash, is address 20. Okay, it's going to be returned as 20 bytes hash, 20 bytes, 160 bits. 20 bytes hash is returned. And then we can also get the counterpart for create. This one we don't need to have the sort. So sort is not used. We simply need to have the create a prefix, different from create a two prefix. And then the sender, which is the deployer. And then the sender's nouns over here. And then return that against the 20 bytes of address. So the content deployer support two regular create two and create function. They are actually a wrapper for a more common, more fundamental create two account and create two account. So this one is actually you can consider it's a conceptual, more unified way of creating account instead of just deployment. So they use the account version is none, so represent the traditional. So this is a more traditional way of deployment, create two and create. And you can consider this two is legacy deployment. So the abstract version is none. Now you have more generic version of deployment. It's called create two account, which provide this new feature. Okay. So we call this to get the address first. Of course, then we're going to deploy on non-system deployment on address. So this is not used for deploy system. I believe it's not used for deploy system contract. And then the next one is create an account. Similarly, but before that, don't forget to increase the deployment nouns for the deployer, for the factory, okay, the caller, basically. And then similarly over here, we already checked that in last video, that this is working pretty well. And then both of them, create an account and create a two account, is going to call a common function called non-system deploy on address. As the name suggests, probably it's used only for deploying non-system contracts. So I'm going to skip the next two function and leave that to the last step. So let's go to the non-system deploy on address first. Make sure the bytecode hash is not empty. Make sure we are not deploying system contract. So we are for sure now we cannot deploy system contracts using this create two, create. And then, so over here, we're going to get a code hash from account storage system contract. Now, this is where we need to talk about a little bit later. This is where we store the account code storage, store all the bytecode for each account or for each smart contract we want to deploy. So we want to check if we already have deployed bytecode hash on this address. If it's 0, then it's fine. Otherwise, we are going to revert. You don't want to deploy twice on the same address. Okay, so and then the next step is trying to get the raw nonce of the new address. And then if the raw nonce is not equal to 0, that means some transaction and being issued from this address. That means this address must be very active. Maybe it's EUA, so you don't want to override EUA either. Okay, so this address has been used. So the next step, the last one is, I believe this is the last one, is perform deploy on address. Oh, I don't think this is the last one yet. Okay, almost, but so we call a common function deploy, perform deploy on address. And then the first thing is you have to ensure the bytecode is known, which is basically contacting another storage called a KnownCodesStorage contract. And over here, you give the bytecode hash, it should return 0. If it's return 1, or it should return 1. If it's return 0, that means this bytecode is unregistered. So you only can deploy a contract whose bytecode hash is already registered with the KnownCodesStorage contract. So now you talk about two contracts. I think, let me pause a little bit. The AcountCodeStorage is used to store the bytecode hash to see that it's a user can get a bytecode hash for any contract as well as the size, because the bytecode hash actually also encodes the size of the bytecode. Okay. On the other hand, KnownCodesStorage only save the flag true or false for giving bytecode to ensure it's known or not. I'm just wondering why these two are not combined together. I think they could. I think that might simplify actually the logic. But I think the reason they separate them is probably architectural design, but more is for gas saving. I will talk about that in a little minute. Why separate them will help the gas saving. And I think it's indeed save a lot of gas because these two will be accessed a lot in the in reality, because every time you deploy a contract, we have to use both of them. And also, if you want to get a code hash or get a code size, we need that as well. All right. So so the next thing is once we are done is we are going to create the account information, because not only we are going to deploy the bytecode hash, but also with the account information. So here we take the input a version and store in the new account information. Okay, and by default, it's going to be sequential unless it's changed later. So during deployment, it's always sequential first. And then we store the account information for this new address for the first time. And then the final step is we are going to construct contract using all these input. So let's go there over here. There are two choices. The first one is, are we going to call the constructor or not? And of course, we have to call here. So it's always true. But sometimes it could be false, and we'll talk about that later. But usually, for the create two, create account, create two account, all these four functions, we are always make this true. That means all these four functions, we are always call the constructor. Okay. And in addition, it's going to check if you, when you deploy, did you also send the Ethereum or not? For example, the constructor is a payable. Then in that case, we are going to call the base token system contractor, which is L2 token, I believe. Okay, which is this one, L2 base token. Okay, L2 base token is going to transfer the Ethereum from this contract to the new address, because when the deployer call the create or create to, the Ethereum is already transferred to the contract deployer. So now we are going to transfer from the contract deployer to the new address, which we are going to deploy the contract on. And then we're going to change the state of store constructing bytecode hash on address. So this is going to call the this is going to call the account code storage system contract to save the bytecode hash into that new address. So I think this is a good time to talk about the purpose of account code storage, how the bytecode is stored in this storage. Interestingly, if you look at this contract, you don't see any state variable. So where do they save it? Well, it turns out, actually, the way they save it, which is accomplished in this function, is right here. Okay, they just use the address of the account or smart contract as the slot number, and then save the bytecode hash right there. So in other words, this gives us a better understanding what a state variable means, because state variable is always there. Every smart contract have all the state variables, and they are well managed by the smart contract. So even we don't introduce any state variable, you have all the state slot there. So when we introduce state variable, actually just give us an easier way, a named way. You can access the slot by name rather than access the slot by, just the slot number. Okay. So let's go over the account code storage now. This is best time, I guess. The first one is you can. The first thing we need to understand is what's it for. Let me go to the account. So a bytecode hash is actually a word. It's in this layout. The first byte is going to save the version number. Right now it's always 01. The next byte is either 00 or 01. 01 means the contract is during deployment. It's called constructing. Means you are still in the process. Probably you're going to call the constructor. And only when the constructor is finished, you're going to reset it back to 0. So 0 means it's constructed, it's completed, finished. Okay, so that's the default. And next one is 2 bytes to represent the length of the bytecode. And then, and this has to be in 32 byte words. So this is not really the length of the being bytes, but really length in terms of words. So that requires the size of the bytecode has to be in units of words, strictly. As a matter of fact, the length has also to be even, I remember. So it's a little bit even higher requirement. So the length has a certain restriction. And then this is actually not a real bytecode hash anymore. This is actually the bytecode hash truncated with only 28 bits because you have to make a room for the first 4 bytes. So this is an example 01, 00. So 1/8 is the length in words for the bytecode. Okay. So this is one word you save in every slot. So this is why you don't need to. You cannot store more information because each slot can only store 1 word. So that's why you only have 1 word over here for the whole bytecode hash. So with that, I'm going to explain that store account constructing bytecode hash. Essentially, you save the bytecode hash, but you need to make sure it's really a constructing version. So this utility function simply check that the state, which is the second byte, is equal to 0, equal to 1. It's a constructing. And then this one is store the constructed version. So you're also checking the second byte is 0. And then this is a mark from 1 to 0. So you're going to check in the beginning originally, you get a color hash, you get a raw version. And then once you get the raw version simply means you just get the original, stored value in that particular slot. And then you check if it's constructed, means if it's second byte is equal to 1. Otherwise, you're going to change that byte to 0 and then save it back, okay, using store color hash. So as we said, we simply store in the particular slot. And then this one, you just read from that slot. So this is write, and this is read from the particular slot one word. And then the get color hash, on the other hand, is not going to just return the raw color hash. It's going to, first of all, it's going to check if the count address is smaller than current max precompile address. If that's the case, we return empty string keycat, a hash for the empty string. Otherwise, we're going to check out the raw code hash for the account. And then if it's a code hash is 0, means there's no code deploy there. And then the account has been used. The get raw nonce is greater than 0. That means it's EOA. So we're going to also return the hash for the empty string. Otherwise, this is important. If the state is during deployment, in other words, the code hash is not completed yet, it's still during deployment, then in that case, we are also going to return empty string keycat. Okay, so this indicates if a contract is still in deployment, not finished yet, maybe it's in the process for calling the constructor, then it's going to return not a code by the code hash, but return a hash of the empty string. And this one is the helper function to get a code size, which is encoded in byte 3 and 4. So one thing you're checking over here is, similarly, we are checking over here is, we are going to make sure the account address is greater than the max compile address. There's a code deployed over here, and then it's not still doing deployment. So only in this case, you'll return the byte 2 and byte 2 and 3. Actually, it's the byte 3 and 4. Okay, index is at 2 and 3. So, but you need to change it to bytes because there it's in words. You have to times by 4. Okay. No, actually times by 32 because each word is 32 bytes. Okay, so that's very much explain how the account code storage works over here. Okay, so let's go back to the store constructing objects. So constructing version of the method. Then if value is greater than 0, that means you're calling with a paywall constructor. Then you have to set the NSG value as a context using this function. I think this is the same function we use in MSG value simulator. So this code is a little bit similar to the MSG value simulator, except here we set a constructor is true, and then this is a false. In an MSG value simulator, a system could be true, could be false, but here it's definitely a false, at least right now. So let's look at this. See, it's a false. for the create account and the create to account, and this for version. But this is true, so that means the constructor is going to be called in the Mimi call. And one interesting is what's going to be returned in this is during the construction process, all the immutable will be returned as a mapping. It's a mapping from 0 to the first immutable value, mapping from 2 to the second immutable value. Each immutable value has to be a word fit into 32 bytes. Okay, so after the constructor function, so this Mimi call will call the constructor function. I'm not going to get into detail over here, maybe another day. So the constructor is finished, then we are going to mark account code hash is constructed. Basically, change the second byte from 1 to 0. Okay, and then we are going to decode the return data, which I said is like a mapping table from the index, first column, to the second column, the word value. And then we are able to call the immutable simulator system contract to set this immutable in that contract. And that contract will manage immutable table for every contract. So this is, you can consider this is the primary key. This is the key, using the new address the key, and then the immutable table as the value for the key over here. Okay, I'm going to explain the branch in the next time, not next time, but in a little while. So I'm going to skip this now, because right now we only use the first branch. Call constructor is going to be true for create two account, and create account, because this is true over here. So we don't need to worry about the false case for now. And then we have two more functions we need to explain. It's called force deploy on addresses. This allows us to batch deploy we can allow this to batch deploy many contracts at the same time. So each force deployment looks like this. We see. Okay. So you have a bytecode hash for the contract you want to deploy. You have a new address, which you already calculated, either using create or create2. So the address has to be given. So, so as you can imagine, as you can imagine, this is not like permissionless contract, because you don't want arbitrary user to be able to deploy a contract on arbitrary address. So this function is privileged function, only can be called by force deployer and the complex aggregator contract. So these two are system contract. Other people cannot call them. Okay. So that's how it works. And then the next one is you can call the constructor or not. It's up to you. So I think only in this case we have this optimization that allow for the system contract. Like the user, when they deploy, create2 account, create2 account, you always have to call the constructor. That's not an option. So the option is only available to the privileged function, force deploy on addresses. Okay. And then of course we can also provide a value, which is the Ethereum amount you want to send to a constructor, and then the input for the constructor. Okay, so let's look at how this is done. The force deploy on addresses, again, has to be authorized, it has to be privileged, have to be only performed by force deployer or complex aggregator contractor. These two, I think it's also here. This is a force deployer, this is a complex aggregator. So only these two can call these two functions, not other people. On this one function, this is only one function. Okay. So over here, you are doing a checking. You sum of the value, and to make sure the sum of the value for different deployment is equal to the received MSG value. So you don't want to people to have play the MSG value attack. Okay, this is very common in the delegation call. Some people might be able to manipulate the MSG value in every delegation. So here you make sure you don't pay more, you don't pay less, and then you iterate through all the array of false deployment and trying to deploy each smart contract separately. And then what you call is you use this .false deployment. So this is actually, so this one is the batch deployment. This one is single deployment. So one question is, why do you want to make this is external and also only call by yourself? Only self means you can only call by this own contract. So why not just make this is like internal? I think I explained in one of the video earlier before. The reason is you want to have each deployment have its own context. In this case, the most important context is MSG value. You don't want to use the same MSG value. You want every deployment having their own SG value. So by doing that, now you actually, as you can see over here, you have its own separate MSG value when you do the single deployment. So this single deployment is pretty similar to the previous non-system deployment on edges, okay, which is right here, non-system deploy on edges. So let's compare the difference between non-system deploy on edges and this false deploy on edges. So this one pretty much is going to be used only for system contract deployment, although you can also use it for, I will just assume this is only used for system contract deployment, okay, for now. So similarly, you have to ensure the bytecode is known by contacting the KnownCodesStorage, the marker. And then, by the way, by default, the bytecode hash should be in the version of constructed. It should be 0 in the beginning for the second byte. And then you also manage the account information. By default, it's a sequential. And then you store it. And then now you're going to call the common function constructed contract. Keep in mind over here, we use a system is false. Okay. And then the deployment call contractor is an argument, could be true, could be false. So this is a little bit different from the create, and then create account, because there the call constructor is always false. Here it's provided by the user. It could be true, could be false. Okay. So let's look at construct contract now. I think that's the last step. So over here, if system is false, we already know that. Call constructor could be true, could be false for this false deploy. We already covered this case. If the call constructor is true, we are going to store constructing by the current hash, then transfer the Ethereum, and then call the immediate call with the MSG value, set its environment, and then mark it as constructed, deal with the immutable. However, if we don't call the constructor, then we don't need to deal with any of those. So in this case, we have to enforce the value, the MSG value is equal to 0. If it's not, then we're going to revert. So because you're not calling the constructor, right? So if we don't call constructor, we still need to make sure the store account constructed code hash is stored. And in particular, we have to save the version called constructed version or constructing version. I think in the previous auditing, there's someone was able to identify the vulnerability here, that when the call constructor is false, means you don't need to call the constructor. The original problem is they set the account bytecode hash is the account constructing version, so that will be getting into a lot of problem because people thought this is not deployed yet, including code hash, including the extension code side and so on. They will all be in trouble. Okay. So I think I explained this already, but let me just go over the KnownCodesStorage too. So what is KnownCodesStorage is for? KnownCodesStorage is going to be used to make sure a bytecode hash is already registered. If it's not registered, you cannot deploy it. And then this also is for efficiency. You don't need to save the whole bytecode, which could be huge, at least big, on the blockchain before you deploy. You only need to save the bytecode hash on the blockchain over here. So I think it's improved efficiency over here. So so that's what a KnownCodesStorage is for. Let's look at the source code. The source code is similar to the ContractDeployer. There's no state variable declared, but that doesn't mean you don't have a state variable to use. You just use the slot number to save your information. Okay, that's the underlying state variable, and when you declare state variable, it doesn't give you actual. It just give you a convenient way to access all the slots. All the state variables are mapped to slots. Okay, so so most functions are called by the system contract, like a bootloader or compressor. For example, this one you can save multiple hash on the block in this KnownCodesStorage. So in the iteration, you're going to mark this bytecode is registered. So published means registered. So this is the batch registration. This is the single registration. You mark is published. Don't be misled by this flag false. This false doesn't mean it's unregistered. It only means should we send to L1? In other words, should we inform such a publication to L1 or not? So which is explained here. So this is a single registration. First of all, you're going to check if it's already registered or not. If it's already registered, so this is only check. If it's not registered, then you do it. Otherwise, you just silent, doing nothing. Okay. So we're going to validate bytecode. Remember, the bytecode hash has been certain format. So first of all, we're going to check the version is always equal to 1. The bytecode hash has to be equal to 0, means it's a constructed version, not a constructing version. And then the length has to be even number. I think this is confirmed. So you cannot have odd number. And in words, not in bytes. Okay. So there's a little bit of restriction over here. And then if we do need to send this notification to L1, then we're going to call the L1 message contract over here. Remember, so it's going to call this L1 messenger. The L1 messenger have two powerful functions. One of them is you can request L2 to L1. You can save the log. You can also save the message. But in this case, we're going to request publish the bytecode L1 publication. Okay. I'm not going to look at this one today, or maybe we can look at it when we talk about L1 messenger contract by itself. Okay, so that's very much conclude today's presentation. So in summary, the ContractDeployer support for, I would say, 4 important functions. You can say 5 because it also supports the batch version of deploy system contract on a particular edges. So we have create two, create account, and create two account, and then use KnownCodesStorage to verify privileges by the code, and use AcountCodeStorage to store my code of each account. And in particular, this support two opcodes called extension code size. You can check the size of the code, bytecode, and then you can also check the code, bytecode hash of the contract. Okay, so thank you so much. Have a nice day.